Hey, Wim Dijkgraaf here, Metal Heaven. I do this video in English because some factories, foreign factories, are involved in the development of the welding calculation. This video is only meant for those factories involved, so this is a quick demo of where we are right now. As a starting point for the session tomorrow to carefully or thoroughly look at the formula. So there we go. A couple of things I'm going to show. Sub-assemblies in rhodium, welding detection, and collision detection. Those are the three subjects. We have created 4 views now, and one of the views is hierarchy. And what we see here is the main assembly with its sub-assemblies. The sub-assemblies with a summary of the working steps at sub-assembly level. And then we see the various parts over here. What is the idea? That for inserts and for welding nuts, we can do purchasing part detection, and when we detect that purchasing part, in the backend administration it should be registered as, for example, a welding nut or an insert. And if that's the case, then we know that at sub-assembly level over here, we automatically can add those working steps or production steps. So automatically the welding nut welding working step type will be added, as well as the appropriate insert working steps will be added based on those recognized purchasing parts. And then of course the estimation for those working steps kick in, and we can do that estimation at sub-assembly level as well as on assembly level. And the idea is that it is that those working steps will be aggregated, so sum up from a child to parent level in the tree structure. So important step that we have full support for sub-assemblies. The recognition step is done, the recognition of those purchasing parts. So that's an important first step. Second step I'm gonna show in another tool. So this is pre-recorded, and this is done in our development tool where we developed a recognition engine. I'm going to play this demo here. So explicit welding seams are recognized. So from the bill of materials in the step file, we can recognize all the welding seams. I will show that in a separate demo. If we have recognized that, then it will be automatically filtered out of the standard bill of materials. And it will be seen as a welding seam. And then of course we want to know what the welding seam welds, what type of materials the welding seam welds. And that's what you see here. The user selects this, and then through by collision detection, we know that this part and this part is connected by this welding seam. And based on those characteristics, for example, it's sheet metal with sheet metal, or it's sheet metal with a tube, or it is sheet metal with a with milling or turning. Those combinations we can use in the welding estimation for this welding, and we also know the full length of this welding. So that's really valuable information for the welding estimation. And here we see another example. So that's also a welding, will be recognized as a welding, and then we can see what this welding seam connects, as well as the length of it, etc. So here we see another example, other assembly with many welding seams. It is selected, and then you see the parts that disconnects. There another welding seam will be automatically recognized, and we see that it connects to sheet parts. So that's that part of the recognition. Well, what you see here is an other assembly which has welding nuts. We select a welding nut, and then you see that also the plate of the sheet is highlighted, showing that also with the welding nuts we are able, through collision detection, to detect which with which sheet it is connected. So independent of how the engineer draws this, and if he applies the correct hierarchical structure in the sub-assembly structure, we know through collision detection what is connected with what. And we will use that for the whole estimation. So that's where we are right now. This same collision detection technique basically is now also ready to do collision detection, and if welding seams are not explicitly drawn, then from the collision area we can kind of simulate the welding seam. So if the welding is not drawn, then we can abstract it from that and start estimating with that. So that's the demo part. Till next time. Thank you. Bye bye.